Hello and welcome. My name is Ahmed and I received in the video comments a comment asking me to make a video discussing the three-tier network topology. So in order to illustrate what is the three-tier network topology as per Cisco recommendations, I will give you a quick overview for the network topologies in general from the beginning in order to build a conceptual knowledge for how network infrastructure in big companies should be. So the first type of network that we all know about it is the small office or home office network. Uh, what I mean by the small office or home network is uh, in our homes we usually have like a DSL modem or VDSL modem or access point. This access point allow us to reach the internet, allow us to communicate with the network outside our premise. This small office network usually consists of a router, and within this router we have many Ethernet ports that I can plug my computer to it, or usually it has like a wireless adapter, so I can connect with this router through the wireless network, and then this device allow me to go through the internet. The problem is this design is the limited scalability. If I have too many devices in my local network, this device won't be able to handle the traffic coming from all of these devices. If I have, for example, like 20 devices connecting to the home router is eligible or capable to maintain the load of 5 clients, 10 clients at max. But as the number of clients grow up, the capability of the home router to uh, absorb the needed efficiency or respond to the traffic in an efficient way will be in a question. So for companies that have a lot of users, let's say we have a small office. In this office, we have like 20 employees. We usually find a router and then we find a switch. This switch will be connected to the router, and then to this switch we will have the 12 employee or 20 employee connected to this switch. So this is the most basic form of network that you could see in any in any small network. When I'm speaking about an office and a company with few number of employees, I will see a switch. The purpose of the switch is to connect the client to the network, and then this switch will have an upstream link or will have a link that is connected to a router. I may also find a device called the access point, and this access point allow us to connect the wireless clients to the network. The access point will be connected to the switch as well. So in this case, if you have a laptop with Ethernet port, you have the option to connect to the router or connect to the switch itself, like this way. And if you have a mobile phone or something like this that doesn't accept the wired connection, you have an option to connect it to a wireless device or the access point. The both scenarios are applicable and are supporting my need to have a network connectivity. So in the first place, why do I need a network connectivity? I need a network connectivity to share a resource or to use a shared resource. As for here in this topology, we have a shared resource in this topology, which is the internet router here. In order to go to the internet, to open Google, for example, I have to use the router. In order to use the router, I need to join the network where the router is connected to. So once I join the network, either from wired or wireless, then I will have the reachability to the router and will send my traffic to Google, and I will be able to open internet without any problem. This is the setup of SOHO network, or as per Cisco curriculum, it's called small office or home network. So the SOHO network is the simplest form of any network that you will ever see in your life. It consists of router connected to a switch, and this switch will aggregate the users who are trying to communicate with this router. The shared resource in the network not necessarily to be the router itself. You may find that for some cases you are building a network to allow many clients to communicate with a single network printer, for example. So instead of purchasing a network USB printer and attach it to every host in the network, you are purchasing a wireless or wired printer that are operating over network, running RJ45 cable, and connected to a switch, give it an IP address, and then configure this printer on all client machines within this network to reach this printer with the specific IP address we just set to. So this is the most simple form of network, and if you understand the purpose of building a network, you will complete with us in the next example. The next example for networks are built on the following assumption. We have more than 100 clients. We have more than 100 users inside the network. So instead of using a single switch to connect my clients to, I will need to purchase switches that are capable to absorb the traffic of 100 users. For your info, most of network switches start from 24 ports and 48 ports. So we have either 24 port switch or 48 port switch. Don't forget, we need some of these ports for the uplink, or let's say in another word, for the connectivity between network devices itself. For example, if I have, like the last example, if I have a switch and I have a router in the upstream, I know this switch have 24 ports in a total. But that doesn't mean I can connect 24 clients to this switch, because I need a cable between the router and between the switch. So the 24 became 23. So I am capable to connect 23 devices to this switch, not 24 clients, because there is a link that will be used to the connectivity between the switch and the router. Okay, so this switch will be capable to run give the reachability for 23 clients. So I need to connect 100 clients. So the single switch will not be applicable, or will not be the perfect example or the perfect solution to connect this much of clients to the network. So I need to purchase a couple of switches, I think another 5 switches. And these 5 switches will need to either connect to router directly or connect to itself. I will show you an example for what I am talking about here. I will connect this switch with the router, and then I will connect this switch to a router, but unfortunately no enough ports on the router to connect to another switches. The routers have a limited density of ports, like 2 or 3 ports at max, and I cannot connect all switches to the same router. So I need an intermediate device. You may think about connecting this switch, for example, with this switch here, and connect this switch with this switch here. And that somehow solves the issue. All switches now have direct connection or have a connection with the router in my topology. But the problem is this switch and this switch are single point of failure, which mean for any reason that this switch or this switch goes down for any reason, power outage, hardware defection, the downstream switch, the switch that is connected to, will lose the reachability as well to the router. So such design is not recommended. I need to connect all switches to the router with the same number of hops. What I mean here is I need to choose a single switch. Let me replicate the setup again. What I need is to bring a single switch, and this switch will be responsible for aggregating the downstream switches, which mean all downstream switches will be connected to this switch, like this way. And this switch, after that, will have an uplink to the router or whatever shared resource that I want my clients or I want the network users to connect to. So in this particular example, I have a distribution switch, and this distribution switch uh, responsible for aggregating the switches in the downstream. So for any reason, when any user on any of the downstream switches wanted to reach the router or reach the internet, it will pass with the distribution switch. Some people call this switch as the core switch. And for Cisco design, they call similar setup with a collapsed core. In this design, we have two tiers of switching. The tier one is the access layer, which we use to allow the clients to reach the network. So when any user try to connect to my network, it will connect his device with any of the downstream switches, these switches. And then after the connecting, this switch is connected with the core switch of my network. In this case, the switch that I am moving right now. And this switch is concerned with moving my traffic from the downstream to the router or whatever shared resource I want to reach. So the problem in this design is I have a single point of failure as well. This switch is just a hardware, so it is connected to power source. This power source could be suffer from outage for any reason. So if this device went down, the whole network will be went down. So this design is not, I will not say it's not recommended, but in order to make such a design, you have to make a lot of precautions, such as you need special switch or special hardware to perform the function of core in this case. By the way, this design as per Cisco is called the collapsed core. Why it is collapsed core? Because it is from the term collapse. If this device collapsed for any reason, for hardware defection or for power source outage, then the whole network will went down. Whole network will be offline. So in order to choose a device that acts as a core, you need to follow a set of criteria. You need to purchase a switch that support redundancy. Instead of having single power supply, you will need a device that capable to have more than one power supply. For example, two power supply, and the two power supplies will be supplied from different sources. As you know, for most companies, we have the ideal setup in companies is we should have two sources of power, two power circuits, one from source and the another from another source. Why? Because when I connect the core switch to the power source, I connect it using two power sources, each source from or each supply, each power supply in the core switch will be from different source. So as a result, if one circuit went down, the other circuit will be capable to handle the traffic. So that was about the power source. What about the hardware itself, the motherboard and so on? Usually when somebody decide to implement a core switch, he doesn't bring a single switch to act as a core layer. He usually bring two switches from the same model, for example, and enable a feature between them called stacking. The stacking feature in Cisco switches and in similar vendors like Netgear or D-Link and so on, they all have the concept of stacking. What does stacking do is aggregating two physical switches to act as a single virtual node. What I mean here is you will have two switches, the two switches with the same number of ports or the same models, and I will connect them with a special type of cables. Then these two switches will act as a single switch. So I will have an option to connect my switches in the downstream with two links, one to the first switch and the second to the second switch. I have many options to make such a setup. Like as I said, we have a concept called stacking. Allow me to write it in a notepad to make it clear to you. We have the option of stacking. We have an option of running the FHRP protocol or first hop redundancy protocol, such as using protocol like HSRP or VRRP. And we have another option, but it is considered advanced and applicable with some hardware or some set of family of hardware families in Cisco called the VSS. So the collapsed core architecture, which I was discussing right now, is consist of two tiers only. The first tier is the access layer, where the user is accessing or attaching himself or herself to the network in order to access the network. And the second layer is the collapsed core or the core layer. So we have here two layers, the core and the access. And remember, the core layer is called a collapsed core because if this core went down for any reason, the whole network will be out or will be offline. So as a workaround for the solution is you ensure redundancy in the core layer. How to ensure redundancy? Through applying the stack concept, applying the FHRP usage using VRRP or HSRP on two different hardware if the hardware is not from the same model, because in order to build a stack, you need devices from the same family. For example, Cisco 3750, you need two switches from the same family or same series of 3750, and of course support the stack ports. And you have a last option, which is the VSS, but it is supported on certain hardware families. It is supported in 6500 and 6800 and 9300, but not 9300, 9400 family from Cisco, right? So this was about the second model or the second type of networks, which is collapsed core. And this type of network is usually used with most of companies that have a little than 2,000 devices in the network. Why 2,000 devices? Because the managing of the switches. You have a lot of switches in the downstream. Each switch will has a limited number of ports, usually 24 port or 48 ports. And in order to connect it to the core layer, you will need a port. يعني it will be hard to connect like 5,000 devices or 5,000 computer devices on a topology like this. In order to make your topology scalable, and if you have a network that have a massive number of end users and endpoints and IP cameras and so on, Cisco recommend you to use the three-tier architecture. The three-tier architecture consists of core layer and the additional layer called distribution, and the third layer called access layer. So the three-tier architecture consists of the core, and under the core layer we have bunch of switches that act as a distribution layer, and under the distribution layer we have additional or bunch of switches also act as access layer. And in this three-tier architecture layer we have, so this was a collapsed core layer. I will just move it to make the screen clear for you. So in the three-tier architecture, as we agreed, we have the core layer. So in the core layer, we have the links from the core to a layer called a distribution. And then in the distribution layer, we have links to the downstream edges. So why to use the three-tier model? Why to use these numbers of layers instead of using the collapsed core architecture? As I said, it is matter of number of hosts or clients within your network. So if you have like 5,000 endpoint in your network, in your local area network, it will be hard to connect so many numbers or so many quantity of switches to a single core or a dual core. You will have a lot of buildings. So in each building, you will have a core for this building. This core will call a distribution switch. So assuming you have a huge a huge factory, and you have like 10 buildings in this factory, and in each building you have like 1,000 devices. These devices not necessarily to be end users. It could be PLC system, IP cameras, sensors, and a lot of devices that could be connected to the network in our in this era, in the time we are living in. So in every building you have like 1,000 devices. So in every building you will need at least 10 switches, I believe 10 switches or 20 switches in this case, and it will not be beneficial to connect the 20 switch of each building to a single core resides in the data center you are hosting your services at. So instead of connecting the 20 switches of each building to the core switch, you will bring a distribution switch that will be reside in the same building where the 20 switches will be at this building, and you will connect each building switch to the distribution switch of this building. And then from this distribution switch, you will grab a link. This link will be connected to the core switch. So what you did here is you reduced the needed ports on the core switch. Just like you reduced the needed ports on the core switch, and you purchased a switch with a lot of ports and placed it in the distribution layer. What else? When you are connecting these switches to the distribution layer, you will have a VLANs in each building. The routing of the VLANs inside the same building will occur on the distribution layer, not in the core layer. Why to do so? To limit the broadcast domain at the distribution layer, which means you will not find unnecessary traffic such as loops or broadcast traffic traversing the link between the distribution and core, which means if for any reason a network loop happened in this building, the network loop will cover this building only or will affect these segments only. It will not be traversed to other buildings. Why is that? Because the routing of the VLANs or the virtual network inside this building will happen on the distribution layer, which means the links between the distribution layer and access layer will be a layer 2 links. But the links between the distribution layer and the core layer will be layer 3 links. We know about layer 2 link and layer 3 link. Layer 2 link mean a switched port that traverse trunking VLANs, multiple VLANs with .1q tag can traverse the link that is configured as layer 2 trunk link. But for layer 3, we are using routing. For routing, we can have multiple links, and these links can be used to load share the traffic without the need to set up a protocol like spanning tree protocol. So if I have two links between the distribution switch and the core switch, and these two links are operating in layer 2 mode switching port, I will definitely have one single port is running and the second port is acting as a backup. But if I have a layer 3 link between the distribution switch and the core switch, then I have opportunity to load share the traffic between the two links and utilize the resources in an efficient way. The second point which I just mentioned was the layer 3 link allow me to separate the broadcast domain as a distribution layer, which means if any problem happened in layer 2 topology here, this loop or this problem will not propagate to other buildings. So if I have 1000 users in this segment and these 1000 users are separated to 3 VLANs, the routing between VLANs will occur on the distribution layer, which means your distribution layer must be a layer 3 switch. It must support routing. And between the distribution layer and the core layer, I will run a protocol such as FHRP. And this protocol is connecting all distribution layers with each other, but through routing traffic. Of course, there are some extra work need to be done in such topology. So if you need to know more about this topology or how to do such a topology in practical example, I am more than welcome to prepare a special video that discussing how to build a 3-tier architecture, what is the switches are used or are commonly used in the core layer, what is the switches are commonly used in distribution layer and in access layer, what is the configuration need to be done on the distribution layer, and how to configure the core layer in respective of routing and so on. So it will be a long video. I cannot do this in this video right now, but that just for a quick overview for the small office home network and why to migrate to the collapsed core architecture. Remember that collapsed core architecture is the routing done on the core switch, and the access layer is responsible for connecting the end users to the network. The core layer in collapsed core architecture or in two-tier topology act as a core and distribution. It is responsible for routing, and it's also responsible for aggregating access layer switches in the network that is running in. And by the way, the collapsed core architecture is recommended for the network with few number of users, like 1,000 and 2,000 at maximum. But for if my company or if my network has a huge number of users, I need to deploy the three-tier architecture, which means I need to have a core switch specifically for core layer, and I have distribution switch, and then I have an access layer switches. And remember, in the three-tier network architecture, the routing between VLANs occur on the distribution layer, and the layer 2 boundaries stop at the distribution layer, because the links between the distribution and core layer are layer 3 links, which give me opportunity to equally load share the traffic on these two links. There are a lot of speaking or a lot of speech need to be discussed here, but I will be more than welcome to answer your comments and make a video if you need to know more or need more details about something. Thank you very much for watching this video. I hope this video was informative for you, and thank you for viewing. My name is Ahmed Hifni, and this was my second video in English for Cisco and network design course. Thank you very much, and goodbye.